as we can see that leading textbooks, they define AI as any device that perceives its environment and takes actions that maximizes the chances of successfully achieving its goal. Yes, that is the textbook definition. I'll be um, giving out a definition in layman's terms. So, artificial intelligence is simply anything that makes machines act a bit more intelligently. So, that's the broad definition of it. So, we come to the classification of AI. Uh, it is classified into three broad categories, as we can see. So, a narrow AI, it's applied to a specific domain. Uh, it can only perform certain tasks, and it makes decisions based on programmed algorithms and training data. So we'll be doing an example of narrow AI today. So just hold on for that. Some of the examples could be Google Assistant, Cortana, Google Translate. That's one. Now coming to general AI, it can interact and operate a wide variety of independent and unrelated tasks. So basically, it means that it can learn and solve new problems by teaching itself new strategies. So examples could be AI in games, such as chess, which learns different patterns, different strategies, and you know makes itself smarter with every game played. Next, we come to super AIs. So this is an AI with a human level consciousness and self awareness. But since we are unable to define what consciousness itself is, we are far from creating one, so you don't have to worry about that. Um, so these are the four best platforms today if you want to make your career in AI or just get started. These are the platforms you want to look out for. So these platforms provide various APIs. As you can see, Microsoft Cognitive Services, it provides emotion API, computer vision API, language understanding. Even Amazon Lex provides with natural language understanding. So they have. So let me just tell you what an API is exactly. It's short for Application Program Interface. So it provides a set of protocols, rules, tools, making applications. So basically, it's a messenger that will take your request and give you what you need. So, as I mentioned, there's natural language understanding. It is one of the most complicated tasks today. They need to be trained on a large amount of data and require a huge infrastructure. So, it's pretty impressive that these platforms provide everything for you uh, to work on your ML projects or whatever. So, I've personally only checked out IBM Watson, and it's got a great user interface. You should really check it out. It can do a lot. So, moving on, we see that uh, this chart, which shows you how each of them is related to each other. So, we see that AI comprises of machine learning and deep learning, as someone had already commented in the chat box before. Yes, it is. And deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. We'll be focusing on machine learning today. Let's talk ML now. These are the commonly used machine learning terms. So uh, we'll be dealing a lot with features and labels. So you need to understand what these are. Features are anything that you provide to a learning algorithm as input. These features can determine the output, which is the label. So we need features. We'll be providing you with features. Like you will need to provide the learning algorithm the features, and it will predict the output as label. So there are different types of models, and we'll come to that later. Don't need to worry about that. Um, So types of data. So there's two types of data, nominal and ordinal. So nominal is where data can be put into categories. Suppose colors, red, yellow, green, blue, orange. They're not related to each other, but they're categories. So that's nominal data. Ordinal data is anything which has a relation between them. Suppose we need to collect feedback from people, right? So we'll ask them to rate the thing in maybe good, bad, excellent. It has some kind of relationship between them. So that is ordinal data. Then we come to categorical data, which the name is, self. We know what it means. So categorical data has variables which can be divided into groups. Examples are race, etc. Moving on. So let's see what machine learning is comprised of. It has learning, uh, three broad learning types, which are supervised learning, unsupervised learning, and reinforced learning. So let's see what each of these means. We'll be dealing with regression today, so need to be focused on that. Someone has raised their hand. If you have any doubts, you can just type it in the chat box and I'll try to reply to it. So anyone who has any doubts, instead of raising hands, just type in the chat box. That will be appreciated. I'll be continuing now. So let's see what each of these terms mean. So coming to supervised learning, we provide labels in this learning type. So we've already learned what labels are. So um, so this is a type of learning where algorithms are trained on human label data, as I said. So we provide them labels so that whatever output it gets, it knows how much it's accurate. Coming to unsupervised data, and it is anything where there is no label. There are no labels or instructions or rules to guide the model. It tries to find patterns by itself. It attracts useful features from the given data and analyzes its structure. Now, reinforcement learning, it's based on interaction with the environment. So it's always growing, correcting itself, and it's based on reward system. Moving on. So I'll be giving you examples so that it helps you understand better. So regression gives a relationship between its features and result. So it's used for estimating continuous values. As we can see, the scale has a continuous value and it's used for estimating that. So if we need to predict the temperature, it will give an exact value, which is 84. Whereas in classification, it divides it into two classes or categories. There's hot and cold. And since our prediction lies in one category, which is hot, it just predicts hot. So going on. This is unsupervised learning. See, we haven't given any labels or we haven't mentioned what is. We just have given it data. It analyzes the data itself and puts in the algorithm and just it's limited to the machine. We cannot do anything about it. We can just retrain it, process the data better, but it's dependent on the machine. It will figure out categories on itself and cluster it, as we say, these are clusters, cluster it into relevant categories. Next is reinforcement learning. This should be trial. Sorry about that. So, reinforcement learning is not dissimilar to how a human baby learns to walk. So it starts walking and it it falls down, it comes across some hurdles, it feels the pain. So that's the punishment it's getting. And when it actually succeeds in working, uh, it succeeds in walking, it is happy, and the machine, analogous to that, gives itself a reward. So it's based on a reward system. It has punishments. The machine gives itself punishments and rewards. So it's a continuous learning process. I hope everything's clear to now. Now we'll be moving on to the general procedure of supervised learning. So we can see that we provide the data and the labels. So these are nothing but features, and this is labels. Um, so we give the data for feature extraction. So what is feature extraction? It's nothing but the process of preparing data, removing any errors, and making it to scale so that the analysis is proper. It's just processing the data, nothing much. Then, after we are satisfied with the processing and the data itself, we'll give it the model. It will predict the output. We have to decide the model ourselves. The machine can't do that. So we give it to the model, and it will give out an output. And we need to evaluate the model. We need to evaluate the output with the actual output we had, which is the label. We'll evaluate that using certain metrics. We'll come to that later. And if we're satisfied with the model, we're satisfied with the evaluation, we'll use the model to predict real life values. We need to deploy it, right? So we'll feed in new data from the real world. Again, we'll do the same process, which is feature extraction. And we put it in the model, which will give out the outputs. This is the thing we actually need. This is why we're doing machine learning. So this is the general procedure. So coming to the Python libraries, we need see Python libraries. These are necessary for us to understand because it has made our life easy. We need to exploit it to our best. So let's see what we're gonna use. There are a lot of libraries, but we'll be using only these today. NumPy, scikit-learn, Pandas, Matplotlib, and Seaborn. There are a lot of different libraries, but that's not our goal for today. We'll be using this, so I'll be explaining them now. So NumPy is used for base n-dimensional arrays and numbers. They perform normal mathematical functions on arrays. Scikit-learn, this has all the machine learning models and metrics that we're going to use. So it's for ML specifically. Coming to pandas. Now, pandas have the tools required for data structures and their analysis. So we're going to using pandas a lot today. We're going to be using everything basically, but pandas is for data structures. Matplotlib is used for 2D plotting. It can be used to plot all these NumPy arrays and everything. And now Seaborn is also for plotting and visualization, but it specializes in ML, where Matplotlib uh, cannot work with data structures properly. So let's go on to actually use this. So people, it would help if you would open your Jupyter notebooks right now and just follow with me to whatever I'm doing. It will help you to gain an understanding of all this practical knowledge. So I'll be changing my screen now. So open your uh, notebook. Um, so I hope you can see the screen. If you can, please type yes, someone. Can you see the screen? Okay, all right, all right. Okay, thank you. So NumPy, has everyone opened Jupyter Notebooks? I know it will be a little bit of a mess to have two screens open simultaneously, but it will be helpful. Okay, so let's start with importing the library, which is NumPy. If everyone could just type in that, import NumPy as NP. We can put anything in here, but NP is the standard variable name given to NumPy. So we'll run that. Um, if it doesn't run, if it's running, it will show a star thing here instead of a number. Now that it shows a number, it means that it has already run. So now we'll generate an array. This is the general syntax for generating an array. np.arange. 1 is the starting value, 20 is the stopping value, and 5 is the number of steps between them. So let's run this. Okay, so running is done by shift and enter. I hope everyone knows that. If anyone wants me to stop to explain a certain thing, just type it in the comments. I'll be happy to help. So we see that it has 4 values given, 1, 6, 11, 16 with a step of 5, as we can see. So arange does not print the last value, which is 20. So keep that in mind. So let's examine an array. I'll be making a new array now. A random variable. Put the starting value as 1, 20, step value of 2. And to print it, just press enter and ds. As you can see, an array has been generated. Now we'll be examining this array. So it has a NumPy offers a number of things. Let's see what they are. So this function shows the dimension of the array. So it's 1, obviously. So we've run out of cells. So the shortcut for adding an extra cell just below it is B. Type in B and see so many things. Okay, moving on. Next function would be this one, give you the size. As you can see, we have 10 inputs here, 10 variables. Next is, so this will give you the data type. Oh wait. Mm, okay, that one would be in Python. Okay, I don't know why it's not working. Let's see. Let's move on to item size. So this gives you the memory staking. So it's four bits per memory per byte. Okay, let's go on to the normal common functions. So if you want to generate an AI, let's just generate another AI array. We can give in our own input. We don't have to do that start and stop and step thing. So this will be our array. If you want to make a two-dimensional array, I just type in something like this. Yeah. So we see it's a two-dimensional array with 3 rows and 2 columns. Oh yeah, I left out this. Let's see where this item size 4 came from. Adding a cell here. Yes, thought. So see, the data type is an integer and 32 bits. Okay. Okay, coming on to the features. So if you wanna make uh, a da- uh, a matrix of only zeros, we can use this. And give the dimension. So we can see there's a lot of zeros. But we can see that the data type here is float because it has the point, the decimal. So if you want to change it to only integer, we can just copy paste this and put the data type as oops, int. It came as in wait. Okay, let's put it as in oh, finally. So it gives a matrix of only integers. So moving on, going to the functions, we can okay, let's try another thing. We have seen how a range works. We'll now see if we need to print even the last digit, which was not possible in a range. We'll use a function called zeros for that. So if we use a function called linspace for that, linspace. These are actually common Python terms only, so you shouldn't have much of a problem. And so, okay, so it starts from 1, it ends at 0, it ends at 5 as we have put in here, specified here. But we can see there's a lot of numbers. There are 50, uh, there are 50 numbers here. So that's the default for linspace. We can specify how many steps we want by just putting in numbers equals probably 10. So see, it only gives us 10 values. And if you want to create a random sample, maybe a random array of random numbers, you can just use this function called np.random. Let's say 3. So it gives us a matrix of random values ranging from 0 to 1. So these are all. This is all and that. Now let's move on to analysis. We'll create a data set, a random data set, and work on it. Let's take this one only. So we've created that. We can get the maximum, for example, np.max. Let's see what. So this is the maximum value, and we can cross check it. Oh, okay. Let's print this too, because that's not. It generates a random way matrix every time, so we need to do that again. Let's run this again. Oh, so this is right here. So that's the maximum thing. Moving on to, there's several functions you can figure out the minimum. And let's do a couple more examples for this. We can find out mean, median, standard deviation, sum. All those are like these mean. And so on. You get the general idea. So we'll be needing this to polish our data set later. Now let's reshape our data set by using the reshape command. And we need to give the dimensions. So we see there are 3, 4. So okay, we could reshape into 4, 3. We see that it has 4 rows and 3 rows. That's how it works. Slicing, it's an important part of polishing our data set. So let's just quickly go through that too. We can pick out the rows and columns we want by doing this. Mm. So this is rows. It will pick out rows 1 through 3. It will not take out the third row. It will only go till 2. And this will pick out the columns from 0 through 2 without excluding 2. So let's see what it does. So we see it has 1. It starts from 0, so 1. So this is from here to here. That's how it works. Moving on, let's go to pandas now. So that is for data structures and analysis, as I've already said. We'll be importing the libraries first. Let's just take numpys also. Importing pandas as PD. And we'll run that. See, you can see the start thing here. It's running. As it runs, let's just work on our thing. Let's create a data set of our own. First, let's create a series of numbers. Let's begin small. And keep in mind the S in CD should be capital. It's the same as A range, almost. Let's print this by typing in X. As we see, this is our data 0, 1, 2, 3, 4, 5, and these are the indices. For that, let's perform some operations on the series, shall we? So let's just say X plus a random number, 75. So we see that it has added 75 to everything, every uh, every variable in the thing. So how it benefits us by not using traditional Python is that we don't have to run a loop. It does everything on its own. So that's pretty nice. It also runs Boolean things, Boolean functions. So let's see. So false, false. So anything greater than 2 is true and false, which is expected. We can also make functions and use functions and use apply to apply the function. So let's create a function. Let's call the function f of x, and suppose x is than 6, for example, because we have to 5. It will return maybe x squared. Let's see if it works. This is how you apply a function. So yeah, it does work 1, 4, 9, 16, 25 as expected. So now let's create our own data frame, get this going. Let's name our data frame as data. You can name anything you want. I'm going to yeah, that seems plenty. And we'll store it as a data frame. So the syntax for doing this is, let's name our data frame as df and use pd.data. So the DNF should be capital, keep that in mind. And data. And we can name the columns. So as you can see, it has 2 columns and 3 rows. So columns we can name whatever you want. In this case, let's name it as X and Y. So this is the, now we can check if our data frame is working. So yeah, it is. Let's perform some operations on that as well. It's getting a little. So we can see, so we'll not be working with data frames which are as small as this. It will have uh, uh, numbers in thousands, 10,000. So we need a good way to determine what a data comprises of. So there's a nice little function here called as describe. It will give out all the things needed, like count, mean, stand. These are self-explanatory, so I won't explain that now. You can also use things like, I will show you things when we walk through an actual project of machine learning. So, oh, I shall put that here. These are the operations basically. We can use functions like describe, info, shape. We can drop columns using drop. Uses the same syntax. So there's nothing new there. Going on to matplotlib. So that is used for plotting graphs. So since we are already running short of time, I will show this to you directly in the project that we're going to do. So moving on to the data, I'll be telling you how to download the data from a data set. So let me share that screen. So, wait, first I'll show you something else. Okay, I hope you're able to see this. Yes, please type yes. Alrighty. So, let's see what goes into making a project. So we'll be using different models such as multivariate linear regression, polynomial regression, precision tree. So we don't need to bother about it because it's mathematics. If you're actually a data scientist, you will need to know the mathematics behind it. I'll just be using it using the basic functions which are already available. But if you want to seriously do something with it, you need to know the math behind it so you can manipulate it yourself. So these are the three models which we will be using today: underfitting and overfitting. So we will encounter this when we'll be predicting the value. So suppose this is underfitting. As we can see, this line is the prediction line, but it does not really accommodate all the actual data well. So it's called as underfitting. So this is balanced. So this is the kind of model we aim to get. And this model is called overfitting. As we can see, the prediction line passes through all the data. I mean, it's a good thing, but it doesn't mean that it will act the same way in an actual model, actual real life situation. So that is also advised to be avoided. So moving on, normalization is a technique used for standardizing the data. It gives a lot of difference. As we can see from the example, unnormalized houses, we cannot really make out what is what. After normalizing it using min-max normalization, this is a function readily available as a function in the library scikit-learn. So we'll be using that. So as we can see, we can really see what's happening out there. So it's required to do so. So it refers to the project we're going to be doing today. So we're not going to be doing today. I will give you a walkthrough of it. I'll give you a basic understanding of how it's done. And so it's going to be about predicting uh, real estate prices. So this is a picture I took from Google, it's California. So let's get our data now. Now you can open your browser and uh, go to this link. I will get you the link now. I or I'll just do it with you. Just go to your browser and I hope you can see the Chrome window. Go to your browser, put in Kaggle. Okay. Kaggle, go to Kaggle and go to search and put in California housing prices. As soon as you put in California, you'll see housing prices. So just go there. And download the data set. If everyone could please mute themselves. All right. So, okay, someone has been muted themselves here. Okay, never mind. So download the data from this button, if you can see that. Let's learn a bit more about our data now. So these are the categories which we'll be dealing with. So our aim is to figure out the house value. So this will be our label, right? We've already gone through this label. We'll be predicting this median house value. And all these are just basic features that we'll use to predict that. So this is what the data looks like. I hope every one of you have downloaded it and try to get it in CSV type, CSV5, which is not even comma separated file. It will come in the option as just go to save as and click CSV. So that will be done. So as you can see, the longitude, latitude, median age of the houses, total number of rooms, total bedrooms, population. So these are all the things that we have. So I'll be going to the notebook right now to show you how we can upload the data. Um, let's go back to the notebook now. Okay, so this is the actual project, what we've all been waiting for. Right. Okay, so we'll be importing all the libraries. It would be nice if you wanted to note it down, you could just take a screenshot or something. Okay. So we have imported NumPy, Pandas, Seaborn, matplotlib.pyplot. So pyplot is a function available in matplotlib library. And sklearn is nothing but scikit-learn. We'll be getting metrics and linear model. Metrics is for evaluation, linear model for getting the model. So we'll run the cell using Shift Enter. It's running, never mind. So we'll be reading the data now. The syntax for this is data_f is any variable you assign. Syntax is pd.read underscore CSV, as is, it's a CSV file, comma separated file. And R is for raw data. So it's nice if we put that in every time because you know, just risk nahi lene ka types. So this is the path path of the file. So if you could go to the your file explorer and copy path and copy paste it here. So let's check out our data. I've already uploaded it. I'll just run the cell. Let's wait till it's running. As it's still running, let's just put in the next function. We will check out our data. For doing so, just put in data_f.head. So it will print the first five rows. As we can see, there are 5 rows. We can check out the data: longitude, latitude, rooms, bedrooms, population. All of these are numerical values except for ocean proximity. So we'll be dealing with that later. We'll correct it later. So that's okay. We have uploaded our data. We have checked it out. We'll perform some basic analysis to figure out what. So since it's a big data set, we don't even know how big it is. So let's figure out how big it is. So look at this. We have 20,000 rows. By machine learning standards, it's quite less, but it's perfect for us to start out. And it has 10 columns, as we've already seen, longitude, latitude. Going on to the info thing. Okay, so it gives out the type of data we have as well as how many type, the number of data we have. So that matches with 20,640. The only thing we see the number doesn't match is in total bedrooms. So there's about what more than 200 values which are null. These are non-null objects, but there are more than 200 values which are null, and all of these objects are float type, except for ocean proximity, as we have already seen. It's nearby, etc. So to correct this thing, that only total bedrooms have 200 less non-null objects, we'll drop all the rows which has any object which is null, so that it brings uniformity to the data. We've done that. Let's see now. As we see, all of these rows have non-null objects, but it has been reduced to 20,433, but that's fine because it's still a large number and we're not aiming for precision today. We just need to learn how it works. So now that we have made the data a bit more presentable, we'll figure out the geographical data. As you've seen, we have latitudes and longitudes. So let's put that into perspective and run this. So we can see that this roughly is like the geographical map of California. So this alpha thing, if we don't put it, let's try removing it. So see, as we can see that it's not really, it doesn't tell you how exactly the distribution is. It doesn't tell you the density of it. So that's why we use alpha 0.5. We can enter any value here. So it gives us a more precise estimation of how dense the thing is. So we're using a scatter plot here, as you can see. PLT is the function we took from PyPlot, which is from Matplotlib, and use scatter plot. This is the syntax. PLT show to show the graph, obviously. So we're still not sure. To get more information on this, we further use this thing. So look at this. So this is what we needed. So the median house value is given as colors here. So 500,000. So as we can see, there's some kind of relationship between the distance, the ocean proximity thing. So these houses are very close to the ocean, and hence these are more pricier. They're pricier than the houses which are inland. So we'll be using that later. See, we need to do all this so that we can figure out what to do with the data, to what model to take. Basically, it makes us